Type 3 is going to be a little bit different. Now we have an exponential and a trig in the same one. Let's go ahead and just start doing this. We'll say u equals, following our limit, we'll make it equal to the exponential. So we have 2x, and then dv equals sine x dx. The differential will be 2e to the 2x dx, and then v will be negative cosine x. So when we apply this, we'll say uv e to the 2x times negative cosine x minus the integral of v negative cosine x times 2e to the 2x dx. When we look at this, we still have a trig and the exponential. And let's make this positive. I'll bring the 2, we can bring the 2 out in front, or we can just let that equal to doing this again. We're going to try it again. You wouldn't necessarily know this the first time you looked at it, but let's see what happens. I need to be really careful about this though. Since I let u equal the exponential and dv the trig, I have to be consistent when I do it again. Otherwise, all you're going to do is undo what you did. So u1 will equal 2e to the 2x dv will then be cosine of x dx, dv1. du1 will be 4e to the 2x dx, and then v1 will be sine x. We have e to the 2x, let's put the negative out in front, cosine of x. Now we have 2e to the 2x times sine of x minus the integral of sine x times 4e to the 2x dx. Does that look familiar? Let me pull that 4 out, and I'll rewrite it to say e to the 2x sine x dx. And everything else just needs to be carried down. Negative e to the 2x cosine x plus 2e 2x sine x. Look at that and compare it to our original integrand. They're the exact same thing. So since our original integral equals I, we can say the exact same thing here. This is minus 4i. So we have I equals all of that stuff. Add 4i to both sides. 5i equals that stuff. How did I move that negative inside there? That's negative e to the 2x cosine x plus 2e to the 2x sine x. Divide by 5. So I equals negative 1/5 e to the 2x cosine x plus 2/5 e to the 2x sine x plus our constant c. Now, some might ask, how come you didn't put it above after we were done integrating? Because that's typically when we would do it. And the answer is we can, but what we're going to do is end up dividing by 5. And so if you have 1/5 of a constant, you still have a constant. So when we're doing this, just tack on the constant at the end. It's just the simplest thing to do. Now here is an interesting problem that combines a couple different ideas, different methods. This is definitely not a straightforward one, because if it was, we would say e to the square root of x. Then if we did a substitution, we'd want the derivative of the square root of x outside of the exponent of e. But it's not there. So that means we're going to have to try something it's going to have to be something different, and that's what this is going to do. I'm going to let u equal the square root of x, and I know I said, wait, we don't have that, but let's see what happens when we do that. dw equals 1 over 2 root x dx, so 2 root x dw equals dx. Now, remember I told you, never have an integral that has a substitution variable and the original one in the same integral. Never do that. So we're not allowed to have this. But what is the square root of x? That's just w. So this will be 2w dw equals dx. Now let's substitute in. We have the integral of e to the w times 2w dw. Now look at that. I'm going to pull that 2 out. So we have integral of w e to the w dw. And now you can see why I'm using integration by parts, or I'm doing this with integration by parts, and I made a w there because I want to say u equals w, so du equals dw. V will equal e to the w dw, or dv, so v equals e to the w. Now we'll have that constant out in front, and we have uv, which will be w e to the w minus the integral of v e to the w dw. Close that up, so we have 2 w e to the w minus the antiderivative of e to the w is just e to the w, so we have 2 e to the w. Let's tack on our plus c. Put back in what w is, so we have 2 times the square root of x, e to the square root of x, minus 2 times e to the square root of x, plus c. If you want, you can just leave it like that. You could have this factored out and say e to the square root of x times 2 root x minus 2. And that is all.